Fred is on his way to school. Brot the bully shows up. He wants his lunch money. Fred says no. Fred says, I challenge you. I think I can lift more weight than you, and if I can, I'm going to keep my lunch money. Brot doesn't think he can do it, so he agrees. Brot lifts 200 pounds. Fred doesn't pick the weights up with his hands. Instead, he gets a barber chair. He puts 300 pounds of weight on the chair. He steps on the pedal and lifts the weight up. How can Fred lift 300 pounds of weight with the barber's chair? The secret is hydraulics, which is using fluids. To explain this, I'm going to talk about Pascal's principle. Pascal's principle says a change in pressure applied to an enclosed fluid is transmitted undiminished to every point in the fluid and the walls of the container. This means that pressure applied at one end of the system is transferred throughout the system. The reason this works is that liquids, remember, are incompressible. This is a picture of a hydraulic lift, and this shows an application of Pascal's principle. We have a fluid, this green throughout. In a hydraulic lift, it would be water. On this end, we apply a force to it, and the pressure will be transferred throughout the fluid. It starts here, and it gets transferred to the other end. What this means is that we can apply a small force here with a small area and get a larger force that comes out in a larger area. The difference you can see on the sides is that the amount that we have to push this smaller force, this delta x1, is going to be much greater than the amount of lift we actually get from the car. But what this allows you to do is apply a smaller force and get a larger force out of it. The mathematical relationship that Pascal's principle leads to is this. Since the pressure is not diminished, the pressure at point 1 equals the pressure at point 2. Remember that pressure is force over area. So this gives us F1 over A1 equals F2 over A2. F1 over A1 being equal to F2 over A2 means that if we apply a smaller force on a smaller area, we can get a larger force over a larger area. So in a barber's chair, the fluid that is used in a barber's chair is going to be oil. And you apply a smaller force to a small piston inside the barber's chair, and it is applied to the larger piston that lifts the seat. And that is how Fred outsmarted the bully. Pascal's principle, I should note, will ignore friction. So any friction in here would change the force that comes out of it because we would lose a little bit. So in theory, to get pressure 1 equals pressure 2, it means that we're going to ignore friction. So how much force did Fred need to apply to lift 300 pounds? Well, we probably shouldn't use pounds because that is going to be in our English system of units. So let's convert our 300 pounds into SI units. We convert it into kilograms, 135 kilograms, but we really want the force applied, so we're going to make it mass times gravity to get our force. So the force that Fred was able to lift was 1,323 newtons. So how much force did he have to put in to get that out? Well, let's say it's a standard barber's chair. The area of the incoming piston is 0.01 meters squared, and the area of the outgoing piston is 0.1 meters squared. So we know force out, we know area in, and we know area out, and we can use that to find the force that he has to apply in. We solve for the force in, and then we're going to plug our numbers in. So he only had to put in 132 newtons to lift 10 times that by using the principle, Pascal's principle, and the hydraulics of his barber chair.